welcome to the Science Circle Talk series. I will be using voice. Attendees are encouraged to use text chat to each other about the topic at hand during the talk. Because I tend to be like a train on a track, I may not respond to questions during the presentation, but I will certainly do so at the conclusion of the session. By the way, in the outer world, I am Robert Brown. I'm a physicist. I retired a few years ago after about 40 years in the silicon chip industry. We'll start with discussing people and time, and then I'll be looking at science and time. So what is our natural sense of time? We know time is a construct, a value that is traceable to astronomical events. The seasons in the year come from the tilt of the Earth's rotational axis with respect to its orbital plane. The day comes from the cycle of light and dark. The month from the orbit of the moon, which creates tides, and by that creates some of our biological cycles. Thus we have the year, the seasons, the month, and the day. The hour comes from ancient Egyptian obelisk, where the arc of the shadow was divided into 10 portions, plus an additional one at the start and at the end of the day, thus 12 hours for the daylight period. The idea of hours with a fixed equal length was not introduced until the 2nd century BCE by the Greek astronomer Hipparchus. I'm going to have trouble with a lot of these words. The unit of the second for time began with ancient Babylonian and Greek astronomers who divided time into sexagesimal, base 60 units. The concept was refined by Ptolemy around 150 CE and later used by scholars until around 1000 CE to define the second as a fraction of an hour. 60 parts to the hour for the minute and 60 parts to the minute for the seconds. The fact that a healthy adult's resting heart rate is typically between 60 and 100 beats per minute, or roughly 1 beat per second, is simply a happy coincidence of being close to the time unit of seconds. The two concepts evolved independently, one from mathematical divisions of celestial movements, and the other from observations of human biology. That was done by Galileo, by the way. What about our mental sense of time? How do we feel about time? When does it feel slow? When does it feel fast? What do we intuitively know about time? Everyone has a subjective experience of time. We remember the past, we see how the past events affected the present, and we speculate about how actions taken now will affect the future. We have history, which is our episodic memory of events. We have causality, which is discovering patterns of events. And we have prediction, extrapolation of imagined future events. This is likely true of other animals in general. Social animals remember to meet with their friends at a particular time and day in a specific place. They also remember where and when they can expect to encounter an enemy. They even get impatient if an expected event does not happen as anticipated. For example, you fail to fill their food bowl. Furthermore, using maze experiments with doors that opened on a timer, we know that mice used in the experiment can remember intervals of time. Basically, they learned that they had to go to a certain spot, wait for a remembered interval, and then the door would open. Do all animals experience time in the same way? Well, probably not. Smaller animals process more events in a given time interval than larger animals. So to a mouse, we seem to move in slow motion. Our reaction time is about a quarter of a second. Cats react 10 times faster. Snakes manage about 4 times our speed. Crayfish have specialized giant neurons that provide an escape response of only 7/1000ths of a second. And there are some predatory insects, such as the mantis, that do even better than that, perhaps a fraction of a millisecond. But there may be one important difference between humans and other animals. We count time and we calculate with time. There is no doubt the cyclic passage of time was essential in prehistoric communities, particularly those in agricultural societies. We are sure they developed rudimentary tools for keeping track of time and dates. Their survival depended upon a deep understanding of natural cycles, and they used various methods and structures to track the passage of time. Tracking time starts with knowing how to count. So a tally stick is the precursor to timekeeping. A possible Paleolithic example is the Ishango bone, believed to be approximately 25,000 years old. This tool was likely made of a mammal bone, marked with a series of parallel lines. It's about 10 centimeters in length. There's a piece of quartz on the end that was believed to be used as an engraving tool. We're almost certain the markings are tally marks, so that a shaman would carry it and he would use it to count things. In that case, this could be the earliest known mathematical instrument. Going even further back, say 40,000 years, there is a baboon fibula that has been found with incised marks. It may also be a tally stick, but it's not as certain about its function. So, before written language, our ancestors were numerically sophisticated, and I like to kid that perhaps more so than many congressmen today. At an early stage, we counted the times the full moon shone between the winters of each year. It's easy to imagine that in prehistoric times, a shaman might carry a tally stick to note how many moons until winter strikes again. Using this to mark the full moon since the warm days, perhaps the shaman might allocate 2 cycles of moon death and rebirth before telling the people it was time to migrate south again. Now, this led to more elaborate means. The Warren Field calendar was discovered in Scotland. This Mesolithic monument, about 8,000 BCE, that's 10,000 years ago, is considered the world's oldest known calendar. It consists of 12 pits arranged in an arc. It's a pretty crude arc. I've seen the layout, and it's closer to a line, I think, than an arc. And it's believed to have tracked the phases of the moon over the course of a year. Now, note this calendar used 12 pits, not 13. So the lunar cycles will fall 29 days short of a full cycle of the seasons. That means the alignment of the pits through the year will drift, in particular to the solstices. They did take this into account. The monument includes a topographical point that aligns with the sunrise on the winter solstice. From this, they could recalibrate the progress of the moon each year. It also is interesting to note this was created by hunter-gatherer people rather than sedentary farmers. Ancient sites like Stonehenge in England and Miso Passage Tomb in Scotland are examples of sophisticated astronomical observatories. They are aligned with the solstice and the equinoxes, allowing people to track the solar year and predict the changing of the seasons for agricultural purposes. Stonehenge was probably started around 31 BCE and finished about 1800 BCE. Miso was created around 2800 BCE. Looking back to ancient Egypt, as we mentioned before, obelisks served as a massive shadow clocks, and that started around 3500 BCE, a good 5,500 years ago. As the sun moved, the shadows would fall on a set of markers on the ground, partitioning the day into morning and afternoon. And this, of course, evolved into more precise sundials. The water clock, clepsydra devices, date back to at least 1500 BCE in Egypt and Babylon. And this is notable because these were the first timekeepers that were not dependent on the sun. They worked by allowing water to drip at a constant rate from a hole in a container. The changing water level, marked on the inside, measured the passage of time. These were particularly, of course, useful for cloudy days or at night. Another kind of interval timer was the candle clock that appeared in 520 CE in China. Such devices were the best available until mechanical contraptions appeared. The mechanical clocks were developed in Europe to fulfill a specific need, to call monks to various prayers, chants, and other rituals throughout the day. These clocks were weight-driven and primarily used for striking bells to announce the time, rather than displaying it on a dial. This development was in the 13th to 14th centuries. One of the oldest public clocks is in Salisbury Cathedral in England, which dates back to 1386. This is a weight-powered verge and foliot clock without a dial. It just struck a bell at intervals. And of course, someone had to wind the weight up each day. Also, I should note this is not a gravity pendulum. It used a balanced wheel to regulate the time. The wheel would simply oscillate back and forth, being kicked by a gear. And that created a special sound. From then on to today, we all hear tick, tick, tick in our heads when we think of time. And that's because of these clocks. Okay, let's go forward to the Renaissance. I always like to think of the Renaissance as having been driven by markets. And markets are driven by trade, including shipping by land and sea. And shipping requires precise logistics, accurate to the hour or even fractions of an hour, most especially by sea, since that's dependent upon tides. So business operations needed a shared understanding of when events would happen. This means you need to have clocks in different locations, keeping the same time. In navigation, it was easy to determine latitude. For example, by this object here that's called the Davis Quadrant. Longitude was a more difficult problem. For longitude, you have to compare the solar time to your location against the time at a reference point, for example, Greenwich. But to do this, you have to carry the reference time with you, and that means you need an accurate mobile clock. The person who's become sort of a folk hero is John Harrison, an 18th century clockmaker. And he created the first clock of sufficiently accurate to be used to determine longitude at sea. And the key development was of a balance wheel that could work even while being jostled up and down and side to side by wave motion. There's a good book, by the way, Longitude, um, that I do recommend. You can find it at your library, or maybe there in the science section of your bookstore there might still be copies. Anyway, this set the stage for conceiving of time as not just being a sequence of events, but rather as something abstract, not tied to events, in the same way that spatial position can be abstracted independently of objects. And that brings us forward to Newton's absolute time. Time exists and flows whether anyone perceives it or not. The same is true of space. It is just there. Newton distinguishes between relative time, which is based on measuring intervals between events, and absolute time, which is imperceptible and is only known by its mathematical expression. To Newton, he felt that humans could only know a relative time. The absolute time was something that was in his equations. In the same way, Newton spoke of relative space and absolute space. The latter, like absolute time, is a requirement of the mathematical universe and is not perceived by humans. There were contemporary objections to this view. Gottfried Leibniz stated that space and time only make sense as relative observations. That is to say, observations between objects and events. 150 years later, Albert Einstein and Ernst Mach upheld the framework where space-time measurement is only sensible for objects and events and is mutable based upon the observer. But the essential notion is that time is a mathematical extraction for the laws of physics. All the classical physical laws treat time in this manner. This leads to the clockwork universe. Time flows. The laws of physics determine all future events. All past events create all future events. And of course, in our clockwork universe, life is just tick, 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 tick. About the arrow of time. If in classical physics the whole universe is a clockwork, this leads to a significant problem. Time is symmetric. The past and the future are asymmetric. It's the way to state it, and it is still unsolved. Clocks can be run backward. From a complete knowledge of the present, we can build a web of causality for the future and a web for the past. We do this because classical laws do not establish a direction for time. For classical physics, one solution was statistical. While individual physical laws are often reversible, the overall macroscopic irreversibility of processes, such as egg breaking and not unbreaking, or heat flowing from hot to cold, determines time's one-way direction. This irreversibility is based on the unlikelihood of moving from a highly disordered state to a more ordered state. Entropy is a measure of disorder or randomness in a system. The tendency for entropy to increase provides a way to distinguish the past from the future. The past is a state of lower entropy, the future is a state of higher entropy. But that is an uncomfortable assertion. It is based upon introducing randomness to physical processes. So what does that mean for the classical idea of a clockwork universe? Every physical conservation law is associated with a symmetry. Time symmetry is a requirement for conservation of energy and vice versa. Time symmetry is baked into our understanding of physical law. and yet we know that it is asymmetric. Another possibility is the cosmological hypothesis. The Big Bang set the evolution of the universe from an initial highly ordered state toward a state of maximum disorder, known as heat death. That's also not a very comfortable assertion. Why should cosmological time affect the passage of time? Furthermore, there is a psychological aspect. Why can humans remember the past, but not remember the future? In a true clockwork universe, the future would be fixed, and yet it seems to be fluid to humans. We make decisions, we see alternatives, so it doesn't seem to be fixed to us. I'll have more to say about that when we bring up quantum mechanics. Okay. Now, Einstein did not overturn Newton, but he extended Newtonian physics. Newtonian physics is Einsteinian physics where relative motion does not substantially reach the value of c. By the way, let me interject here. C is not the speed of light. Photons are often moving at speeds less than c. The value c is a universal property that limits the motion of all physical objects. In special relativity, we are examining the relative motion at constant speed. We find that at very high speeds, approaching c, for a moving observer compared to a stationary observer, the coordinate system will be transformed. The flow of time will be different for each observer. And that would have horrified Newton. In general relativity, we see this extended to accelerating systems and to systems in space-times strongly bent by huge masses. So time is not constant. The web of causality is. Quantum mechanics offers interesting routes to understanding the arrow of time. The wave function collapse, if wave functions do collapse, and there is some disagreement over that, could create asymmetric time. The collapse is an irreversible process that appears to violate the time-symmetric nature of the underlying quantum equations. This irreversible process could be the source of the quantum arrow of time. Some scientists believe the irreversibility and the increase in entropy result from quantum decoherence, where quantum systems interact with their environment and become entangled. The loss of information to the environment prevents the system from returning to its original state, which gives the appearance of increased entropy. An alternative perspective suggests the arrow is a fundamental aspect of quantum physics itself. This theory argues that the quantumization procedures needed for quantum field theory inherently select a causal direction, meaning reactions only occur in one direction. Now, none of these ideas from quantum physics has the strength of the thermodynamic statistical proposal. The low entropy Big Bang and resulting thermodynamic arrow provide a coherent explanation for the other arrows of time, such as the cosmological expansion and the unidirectional nature of causality. Our psychological arrow, the memory of the past but not of the future, is also thought to be a product of the increasing correlation and entropy. In addition, and quite importantly, the thermodynamic proposal can be falsified. We like to have physical theories that we can test and prove to be wrong. If we ever observe that the universe is becoming more ordered, which is to say entropy would be decreasing, the proposal is wrong. And finally, the entropy arrow of time does not require us to create new laws of physics. In some theories of quantum gravity, this might not be a time may not be a fundamental property of the universe at all. It could be an emergent property, meaning that it's a useful concept for our scale, the human scale, but may not exist at the most fundamental level of reality. Arthur Eddington raised the modern objections to understanding the symmetry of time in 1927, and you should note that that year follows major developments in relativity, gravitation, and quantum mechanics. And we do continue to view this as an unsolved problem from that perspective. A common way of looking at it is to envision a film of events, that all of time is broken into a set of frames of existence. Now, with time symmetry in the physical world, running this film forward or backward would seem realistic. You don't see any physical laws being broken. But that simply isn't true. Oh, by the way, talking about the egg breaking and unbreaking an egg, if you know the exact position and velocities of all the atoms of that egg, makes perfect sense running backward. It's just phenomenally complicated. Okay, but humans immediately spot inconsistencies upon the unbreaking of eggs, water flowing uphill or snow appearing on hot days. And worse, this distinction appears to be mainly in the macroscopic human-sized world, in the cosmological Big Bang universe, not in the microscopic quantum world. The clockwork universe is fully determined. The future will be an exact product of the past. The present is just a perception by minds that do not realize they are part of the clockwork. Okay. This is also called the classical block universe. It is a web of causality that encompasses everything throughout time. This philosophical universe is called eternalism. It denies free will, it denies purpose. It simply says things are as they are. But is that true? Well, many theoretical physicists believe it is. As it happens, I'm not one of them. I believe that true randomness does exist, and the implication is that the future is not predetermined, and the past cannot be precisely reconstructed. The problem with this speculation is that it is impossible to prove or disprove. Accordingly, it's not a valid hypothesis. It is a whimsical speculation or whimsical belief. You can't have a hypothesis unless you have a test for it. Okay, so at this point, let's do a bit of a pivot. I would like to talk about the labeling of the errors of human history. So we'll get away from the murky questions of physics and metaphysics. People need to organize and make sense of history. And we do so by partitioning the past into blocks of time and nested labels for different aspects of history. As it happens, there is a proposal to establish a new partition to our history, the Anthropocene. This will be a geological epoch where humans have become a dominant force in shaping the planet's geology and ecosystems. Now, this is controversial, and how does it fit in with the existing geological divisions of history? These divisions range from grand, encompassing eons to smaller ages. It is notable that closer to our present day, the more minor divisions we make. In the distant past, we were impressed by cosmological events such as the solidification of the Earth's surface. And the more recent times, the glaciation ends and we make a big deal out of it. Basically, for the events that are closer to us, more important to us, we make smaller and smaller divisions. The geological timescale is organized from largest to smallest units as follows. We have eons, eras, periods, epochs, and ages. To discuss these divisions, we use the unit of MA, which stands for millions of years ago, and also the unit GA for billions of years ago. The Hadrian Eon, which is our earliest that we make note of, that is when the Earth solidified from molten rock. That time the moon was also created by an impact event, and water may have been delivered to the planet by comets. The Archean Eon is when our continents formed and we saw the first signs of life. The Protozoic Eon, we had oxygen-producing life and multicellular life. And the Phanerozoic Eon is the one that we are presently in. This most recent eon translates to being the age of visible life, and it is characterized by the abundant fossils we find in the ground. Within our eon, we have these eras. We have the Paleozoic era, the Mesozoic era, and the Cenozoic era. The most recent era, the Cenozoic, is the era of mammals, which followed the decline of the great reptiles. By the way, there's been some revision of our thought on that. You know, we used to think that the reptiles were extinguished quite quickly by a massive meteor impact and a resulting global winter. Now they say, yes, that certainly happened, but the actual decline was a bit more drawn out than we tend to portray it. In our era is also when we start talking about scenes. The word scene means new or recent. So within the Cenozoic, we have the Paleogen period, the Neogen period, and the Quaternary period. And within those, we have a set of epochs that we did further subdivide our history into. And let's see, I'll skip, okay, I won't skip over all of it. In the Quaternary period, now this is a hard word for me to pronounce, we have the Pleistocene epoch and the Holocene epoch, the latter being our present one. And there are many other periods, because in the Mesozoic era, you of course know about the Cretaceous period, the Jurassic period, the Triassic period, as seen in recent movies. But we're going to talk about mammals, so that's where we're going to focus. So within the Quaternary, I mentioned the epochs we have, and our Holocene one being our current one. The Anthropocene one has been proposed as a future epoch for us, but there are other proposals. Very simplified timeline. In the Paleocene, small mammals and primates appeared. In the Eocene, modern forms such as horses, rhinos, bats, and squirrels may have had their first appearance. And then finally, we had global cooling in the Eocene, which forced the further evolution of mammals. The Miocene saw the great apes, and the earliest types of men appeared in the Pliocene. Okay, so Holocene means new hole. That's our current one. and it is characterized by a relatively warm and stable climate compared to the ages before. And that allowed for the development and expansion of human civilization, agriculture, and of course our significant impact on the planet's ecosystems. I should also mention that within the epochs, we also have subdivisions called ages, and geological environmental changes such as global drought define these. The Mahelian age is the age that's most recently defined. But for human development, people typically subdivide that further. So you have the Paleolithic, the Neolithic, the Bronze Age, the Iron Age, and the Industrial Age. All of those are part of the Holocene epoch. Okay, now what about the Anthropocene, or rather the Age of Man, which is to succeed the Holocene. This is based on human activity, including climate change and pollution, having caused a global scale impact on the Earth's geology and ecosystems. It is still a subject of debate. People don't know where we should say it starts. Some people say it started back in the 1800s. Other people say its start is yet to begin. Who knows? And it's rather sudden. I mean, the Holocene is only 10,000 years old. And previous epochs, in some cases, lasted for 2.5 million years. So it's interesting that it's going to be so short. But that might be justified because, as I said, as events become closer to us, we put more importance on them, and thus our intervals for the divisions become smaller and smaller. Another objection is that while there certainly is quite a human impact and is significant to human existence, the Earth ecosystem will likely survive us. We can kill ourselves, but we're not going to kill the planet. Now, some writers, with tongue-in-cheek, have suggested we're entering the Plantational-Holocene, the Cthulhu-Cene, the Growth-Cene, the Econocene, the Pyrocene, and the Necrocene. The Plantation-Holocene proposes that the current ecological crisis is rooted in the history and logic of colonial plantations, which involved forced labor, resource exploitation, and a system of control and commodification of nature and people. Now, the Cthulhu-Cene is a concept from Donna Haraway, who was a zoologist, and actually quite a bit more than just a zoologist. By the way, I should mention Cthulhu, of course, comes from H.P. Lovecraft's stories as one of the ancient gods. And according to Lovecraft, the name is actually unpronounceable by any human throat. Anyway, the epoch he is proposing is where humans must learn to live in balance with all other creatures, acknowledging our interconnectedness rather than our dominance. And I believe she is suggesting that we do that or die. It emphasizes being part of the Earth's processes rather than separate from them. The Growthocene, that term describes the current era as one characterized by a relentless drive for constant economic growth, which relies on increasing biophysical throughput and continuous capital accumulation, leading to ecological destruction. The Econocene is proposed by Norwegian environmental sociologist Anneli Norgaard, and this concept emphasizes how the prevailing logic and institutions of economics have become central to our understanding and engagement with the environment, shaping our policies and actions. Pyrocene, that is proposed for the significant impact of human-driven and amplified fire in shaping the planet. And finally, the Necrocene, well, that refers to destruction. That refers to death. That reflects the destructive and lethal aspects of human activity. So, I have a different thought. Maybe the next division should be when, and I should say if, humankind is established on other worlds. Here's some speculative names that are being kicked around the information sphere for that. The Astrogeocene, which you can find in, of course, Astro, Geo, and Scene. This term signifies a new epoch when the human processes are significantly influenced by human activities in space. It highlights the expansion of our species beyond our planet of origin. The Exocene, exo meaning outside, suggests a period defined by humanity's reach beyond Earth. The name focuses on the beyond aspect of human expansion, making a clear break from purely Earth-centric existence. The Technocene is proposed in 1988 to note the time of significant human technological development. And for an epoch focused on humanity moving beyond Earth, the Technocene would specifically highlight the role of advanced technology in enabling space travel and settlement. The Sidereocene, which is drawn from the Latin word sidera, meaning stars, this name would denote the new age of the stars, and it poetically frames the human journey as a celestial one, rather than one defined solely by our technology. The Noocene, that's N-O-O-cene, was proposed in the 1920s by scientists Vladimir Varadosky and Pierre Telhad, and it's a concept that is a layer of thought and consciousness enveloping the Earth. And this epoch would represent the expansion of human intellect and knowledge beyond the terrestrial sphere. So, there are our thoughts. And at this point, we have about 17 minutes left. Why don't we open it up to discussion? So, would anyone like to chime in with their thoughts? Well, do we have time? Time for discussion, but in human terms, not planetary terms, and not celestial or cosmological terms, is time running out? The TV series The Expanse was such a great view of what it will be like when humankind expands beyond Earth. How do people feel about the difference between the clockwork universe and a universe that has randomness built in?
Well, since we can use our voice, I'm going to use my voice. Yeah, that's an interesting question. If we don't have randomness, if it's just a clockwork universe, if it's just a movie that we're just puppets, and what we do doesn't really matter. But if it's random, then you actually have some control, and so you are responsible for your actions. So I like that one better, because I like to feel like I'm responsible for my actions, and that others are as well.
Well, there's also another viewpoint, and that is that even if the universe is a bulk universe, a big block of causality and events, nonetheless, in any way you want to try and define it, you do make decisions. And as best as we can, that is free will. So even though there's predeterminism, you still have free will. Seems contradictory, but that could be the case. Of course, others, let's see, I believe Brian Greene, most notably, most publicly, uh, believe that all decisions and all causality simply branches out. So you do make decisions, but uh, each time you also make the other decision, and at that point there's then two yous. Of course, that works straight down to the quantum field levels, so it gets rather messy. And I don't really believe in the multi-universe myself, simply because it's A, kind of messy, and B, there's no way to prove it or disprove it. So again, I characterize it as a whimsical belief. Well, the gaslight comment, I guess that is referring back to Newton, because of course Newton did not have the advantage of many of the observations that we made 150 years later. But no doubt about it, Newton was brilliant, and his notion of absolute time and space fitted well with what he saw in his equations. There were attempts to measure the speed of light even before Newton. I'm trying to remember who did it, but there was one individual who had him and an assistant climb adjacent mountain peaks. And the idea was that he would flash a lantern, and his assistant would then flash a lantern when he saw the first flash, and he would time the interval. And of course, he found that he was unable to time it. But people were aware of the fact there should have been a possibility of there being a speed of light before them. Yes, I think it was Galileo, but I wasn't going to say because I just didn't remember precisely whether it was him or not. Well, as I said, the Egyptians first subdivided the day, and they did subdivide the daylight portion into 12 units. I think they did 10 units for most of the daylight areas because they had 10 fingers, and they added extra ones on the beginning and end, probably to accommodate the shift of daylight and twilight. They didn't standardize it into equal interval hours until much later. And as for the night, it was just night. They didn't even subdivide that until much later. And when they did, they simply said, let's mirror the day and give the night 12 intervals as well. As mentioning the curvature of the universe, in particular in the presence of large masses, we weren't really able to do much about that till we had atomic clocks and satellites, although there was a good measurement that was made with a high altitude plane. But to do that kind of thing, we really have to be moving out into the cosmos to see the cosmological factors. Well, the thing about base 60 and the various divisions down to base 12 is because people just naturally like to make even divisions, that seems just to be the way we like to go. Well, perhaps more important for the prehistoric people observing the equinoxes was not the 50-50 of day and night, because they couldn't really measure that. But what they did see was the high point and the low point of the sun above the horizon. And that would have been much greater importance to them. So, the summer solstice when it's at the high point, and the winter solstice when it's at the low. And as for the equinoxes, roughly in between. As for time being an illusion, something we just perceive, well, yeah, if the block universe is simply a big web of causality, then it is an illusion. It is just something that we see this web, and we impose a way of measuring from one causal node to another on top of it. I think that the definition of east and west came from the equinoxes and not vice versa. And again, we didn't really probably recognize them as equinoxes until people had good ways of measuring intervals. Our ancient shaman, he had his tally stick that would let him count moons and so forth, count sunrises. But as for measuring intervals, that's a little bit trickier. And for all you hitchhikers out there, I remind you that it was noted that time is an illusion and lunchtime is doubly so. We're just 3.5 minutes short of the full hour. So any last comments, and we'll just say goodbye and clean up.